Section 4.9, Escape Speed. So we talked about how if you launch a projectile tangential to the surface, like parallel, and you get up fast enough, and assuming there's no air around, you could get an object to go in orbit around the Earth. But what would happen if instead of trying to shoot it parallel to the surface, you launch the object straight up into space, perpendicular to the surface of Earth? You would expect that it, just like everything else, if you throw something up in the air, gravity is going to pull it back down. This is in general true. But if the projectile can get up to a speed great enough, it can actually pull away from the Earth's gravity. And this is how we're able to launch rockets into space and into, send people to the moon. The critical speed, the speed that object must meet, is what's called escape speed. And escape speed is basically just the speed you need to travel in order to break the gravitational pull of some object. So escape speed changes for different objects in the solar system or in the universe. The escape speed for Earth is about 11.2 kilometers per second. So if you can go 11.2 kilometers per second straight up, then you'll get out of the Earth's gravity and you won't fall back down to the Earth. Now, the trick is that just like with any rocket travel, and that's why sending rockets to space is tough, that most of the work is done close to the surface. The biggest problem with rockets is that they have to have fuel, and fuel takes weight. And so you have to add more fuel to lift the weight of the fuel you had. But then if you add more fuel, you have to add more to lift that weight. And so it can kind of compound over time. And that's why you can have trouble getting things up into space. But if you can get any object to travel 11.2 kilometers per second perpendicular to Earth's surface, then it should leave Earth and not fall back to the Earth. Obviously, for other bigger objects, you'd see different escape speeds. For the sun, if you wanted to escape the gravitational pull of the sun, you'd have to travel at 620 kilometers per second. For Jupiter, it's about 60 kilometers per second. And for something like the moon, it's only 2.4 kilometers per second.